Welcome back to the Advanced Microcontroller series. In this session, we are learning about microcontroller interfaces with tactile switch. And here is the agenda, introduction and circuit on board. So tactile key as digital keypad. So in the circuit, in the schematic diagram, here you can see there is 6 tactile keys are there. Switch 1 to switch 6. It is connected from RB0 to RB5. So switches are the input device. This is the pull-up resistor circuit. The same thing, 6 keys connects to the port B, means RB0 to RB5, and these are the input devices. These are the symbol of tactile switches. This is open switch and this is closed switch. Okay, let's write the code. So in the previous session we discussed about level detection and state change detection using the switch RB0, but here in this session we will use RB0, RB1, RB2 up to RB5. We using all the switches. Okay, let's write the code. So here I am going to write main.c. So there is no space, so I am writing digital keypad here. Digital keypad .c. So in the main.c, so what we need to write inside the main.c? So we need to write init config function, right? So all initialization code should be there. So static void init config So here we need to write all the initialization code. So we need to consider initially LED array should be off. So here in this code what we will do means we are writing both level detection and state change detection. How we will do? So we will do using this one, read key equals to read digital keypad. So using this function digital keypad. So it has two operating modes controlled by the mode parameter. So in this code has two operating modes. One is level detection and one more is state change detection. So that can be handled by this parameter. So this is mode parameter. So before that, what we need to do? We need to write init digital keypad. So this function. Yeah, so this is what main.c. So now here you can see it will decide which mode, whether it is level detection or state change detection. This is the initialization code, and here we need to write all LEDs are turned off initially. Okay, then we need to consider TRISP equals to 0. Why? Because LED is output device, isn't it? That's why we need to write. So here I'm not going to write LED array DDR. So yeah, we need to write that one. So here I'm writing just TRISP equals to 0x00. Okay, let's write this one during the compilation. So TRISP equals to 0x00. So in the main.h we need to write LED array DDR. Why? Because it's easy to read. So it's easy to understand. This code is written for LED. But can I write port B? Can I write port B? No. In the switch we are using RB0 to RB5. So instead of that, here I am using port D. LED is connected to port B. So we can connect the LED to port D also. So I am using port D here for LED. Yeah, this is what initialization function. So now after the initialization we need to write main function. So here I am writing void main. So now, can we write port B for switches? No, right. Port B is from RB0 to RB7, but here we having switches RB0 to RB5. So we can't write port B. So what we need to do? So what we need to do means, so here we need to write for TRISP B. So here we having 8 pins, isn't it? TRISP B7, then TRISP B6, then TRISP B5, then TRISP B4. Similarly we having TRISP B3, TRISP B2, 1 and 0. So here, yeah, we need more space to write this. So I'm starting from this. Okay, I'll reduce the size. Okay, so now, yeah, so now what we need to do, yeah, sorry, here this is not 7, TRISP B3, next we having TRISP B2, then we having TRISP B1 and TRISP B0. So in the port B we having 8 pins, TRISP B7 to TRISP B0. So now TRISP B, so here I am writing. So here first we need to find the input lines. So what are the input lines we having? After that we need to find when switch is pressed, switch 1 is pressed, then switch 2 is pressed. What you will get, that we need to write. So this is what for input lines. So now TRISP B7 is not there, right? So that is 0. Here I am considering 0, and TRISP B6 also not there. So we having only 6 switches that is connected to RB0 to RB5. So here rest all RB tris B5, tris B4, tris B3, tris B1 I am considering as 1. So now 0 0 1 1 means what? So in the hexadecimal 0 0 1 1 means what? So here you can see, okay, sorry. So here you can see 0 0 1 1, where it is 0 0 1 1 means, sorry, 0 0 1 1 means 3 and 1 1 1 1 means F, isn't it? So here it is 3F, we need to write 3F. So and here we need to use the OR operator for all input lines. So here we using all input line, right? So here we written OR operator. So after that here we need to apply tris B or 0x3F. So now we need to write, so x and 0, x or 0 is nothing but what? X. So OR operation means, so it is like logical addition, okay. X plus 0 is 1, x or 1, x or 1 means 1, x or 1 means 1. So here we need to write this in straight, otherwise we will get confusion, right? See here, x or 0, x or 0, x11, x11, x11. So here we need to write x11, then x11 and then x11. This is what? Input lines. So for input lines, what we need to write for input lines? So here I am going to write for input lines, what we need to write for input lines? Input lines. So here I am writing for input lines tris B or 0x3F. Now we need to write for the released switch. So released switch. So what we need to do for the released switch? Okay, now here sorry, it's showing, why it's showing here? So okay, this is not needed. So now, yeah, here we are discussing about this. So now for input lines, what we having? Tris B 0 OR operation we having, right? So now here you can see for released switches we are using AND operation, not OR operation. So here I am directly editing this only. Okay, for released switches here we using AND operation, and we need to consider same. Now tris B and 0x3F means what? AND means logical multiplication. So x into 0 means what? 0, and x into 0 means 0, and x into 1 1, x and 1 1, the same thing, x and 1 equals to 1. So now here you can see this is 3 and this is F, same, right? So for released switch we using AND operation. So similarly we need to find when switch 1 is pressed. So then what will happen when switch 1 is pressed? sorry, this is AND. Okay, so when switch 1 is pressed, what will happen? This RB0 is 0, isn't it? When we press the switch 1, so here I am considering 1, this is 1, and this is also 1, this is 1, this is 1, and when you press the switch 1 means it is 0. So now here we need to do the AND operation. So AND operation, 0 and 1, so that is what? 0. Similarly 1 and 1, 1, this one same, and this is x and 0, 0, x and 0, 0. So this is what? AND operation when switch 1 is pressed. So 0x11 means 3 and 1110 means what? Here you can see 1, okay, I am just hiding this. 1100 means that is C, not C. 1110, so that is what? E. 1110 means E. So now, so that is what? PICB and 0x3E. Here we need to write E. So similarly we need to find the switch 2, switch 3. So what will happen when you press the switch 2? So this is 1 and this is 0. So what will happen here? This is 1 and this is 0. So for switch 1 means what? Same, PICB and 0x3E. For switch 2, 0x, so 0x11 means 3 and 1101 means what? Here you need to see 1101 means D. So see here 1101 means D. So this is D. Similarly we need to do the same for all. Okay, switch 2, switch 3. Switch 2 is done. Similarly we need to do for the switch 3. So what will happen when you press the switch 3? It should be 1 and it should be 0. So now this is 1 and this is 0. So now 1011 means what? So for switch 3, 0x3B. Similarly we need to write for the switch 4, that is 0x37, and for switch 5 we need to write 0x2, sorry not 3, 2F, and switch 6. There is total 6 switches are there, right? 0x1F. So this is what? For all the switch we need to write like this. Yeah, now we got the values, right? So now we continue this code. Okay, so in the header file we need to write, then no need to write again like this. Okay, so in the header file I am going to write so here in the digital keypad .h, so here I am writing hash define this switch. So hash define switch 1 means 0x3E. Similarly we need to write for all switch 2, switch 3, switch 4, switch 5, like that we need to write. So this is what header file. In header file we need to define the switches. So then directly using the main.c file. So here we need to write after this. So inside the main function, so here directly we can use, instead of writing this, so how we should write, so before that this key is used, right? We need to declare the key. Okay, so here I am writing unsigned char key. So we need to declare that. So after that we need to call function, that is init config function call. Then we need to use the infinite loop. So here I am using while 1. So what will happen here? So we need to write this one, key equals to, so it will read which mode, whether it is state or logic detection. So after that, so sorry, before that I am going to delete this. Then I hope you get this logic, so I am deleting this also. So now after this what we need to do, so when you press the switch, when key equals to switch 1 means this one, what will happen, the LED should toggle. So here I am not going to consider entire port, instead of that I am considering single LED. So that is RD0 is equals to, so here I am using complementary function, and RD0. So now after that we need to consider some delay. So here I am going to write one delay. So for unsigned, so here we need to write some delay. Yeah, this is what, this is why we use it. When you press the switch 1, the LED should toggle. Sorry, this is not RB, this is RD. So similarly we need to write for the switch 1, so sorry, switch 2. So what we need to do here, when writing for switch 1 we need to write, when writing for switch 1 we need to write else if function, not if again. So here we need to write else if, and here switch, not switch 1, so here we need to write switch 2, and here we use RD1, not RD0. Similarly RD0, then we need to consider delay. So similarly we need to do the same thing for all the switches. We having 5 switches, right? So we need to do the same thing. Yeah, in the digital keypad, so here we written only this switch, but we need to define keypad also. Keypad means here we considering what for the keypad port, so that is port B we considering. So and hash define all released. So here we need to write this also, released switch and input lines. Then we need to write level detection and level also. We need to define here. So what is hash define level and level detection? Okay, we need to define under the header file. And so yeah, under the main.c, here we need to write we need to define LED. So LED is used for port D. You need to define this one under the header file main.h. Okay, let's write the logic now. So here we having this, right? So when we call here state, then what will happen? State change detection, isn't it? So we need to write the logic now. So here, so we need to write the logic now for level detection and state detection. So how to find the logic? So to find the logic, what we need to do? So initially, we need to write one init digital keypad function. So in that we need to write, so okay, I am writing this here, while init, all initialization code should be inside this. Okay, so here init digital keypad of white. So here under this all your initialization code should be there. So initially we need to write set keypad port. We need to set the keypad port as input, isn't it? So how to set? To set the pin, which operator we will use? OR operator. So here I am going to use the OR operator. So keypad port. So keypad port DDR is equals to, so we are using OR operator. So keypad port DDR or input lines. So input lines, we already discussed about the input lines, isn't it? What are the input lines? So this is what initialization code. Now we need to write the application code. So here we having two modes, right? So one mode is level detection and one more is edge detection. So now let's try the level detection logic. Okay, so before that we need to write unsigned char. So when this function will be executed, so in the previous code we used this function, right? Read digital keypad. So here we need to write the same thing. Here we need to write the same thing. Sorry, what happened? This is layer 3 is not required, layer 2 is not required, layer 1 it is, right? So okay, I'll create new layer and I will write it here. So now now we need to write the unsigned char. Which function we call it there? Read digital keypad. So here we need to write the parameter. So here we using unsigned char mode. So here we need to mention in the previous code main.c we need to mention which mode it is. So here we considering two modes. So okay, before that, yeah, okay, let's write the modes. So if mode equals to level detection, then what it should return? So return keypad port. So here we considering ports, keypad ports, then and input lines. Yeah, that's all about level detection. When it detect, if the mode is level, then this will run keypad port and input lines. So what will happen during this level detection? When you press the switch, LED toggling, isn't it? When you long press LED toggling. But in the state change detection or edge detection, what will happen? So if mode is level detection, then this one will execute, else this one will be execute. So now here we using two conditions. The same condition when you press the switch 1, that is same condition we using, and also we using once. So what do you mean by once? In the previous session we discussed once means what? For the edge detection. So it ensures the action happens only one time per press. That is what once. Okay, before writing once we need to define. So here we need to declare what is once. So unsigned char once equals to, initially it is 1. So here initially it is 1. Okay, now here we need to write in the else condition. So else, so here we having two types. Okay, so if keypad port, so if keypad port and input lines, so if keypad port and input lines not equals to all released. So if keypad port and input lines not equals to all released, and once. So here we having two condition. It should check the two condition, whether this is true and this one is true. So if this is true and this is also true, then this is true, then this statement will be executed. So what will execute? So once equals to 0. After this execution, once equals to 0. Then what it will return? Return keypad port and input lines. The same thing it will return. But here in the edge detection, no toggling happens. So okay, this is one condition. So another is there. What means? So else if, so the same condition, keypad port and input lines are equals to all released. In the previous condition, not equals to all released, but here it is equals to all released. But here we having two condition. Condition 1 is this one and condition 2 is this one. But in the else if, we having only one condition. This one only we having. And here it is equals to, not equals to. So not equals to. So when you release the switch, what will happen? Again once equals to 1. So what is the logic? Did you get this one? If and else. What is the logic here? So after this execution, it will come out of the loop and return all released. So here it will return all released. So what will happen in the state change detection? So how it will works? So initially once equals to 1. So here we return initially once equals to 1. So switch 1 is pressed. So when you press the switch 1 and once also 1. So once also equals to 1. Then what will happen? LED on. So condition becomes true, right? LED on. Then what will happen? Once equals to 0. Why it is 0? So prevents repeated toggling while holding the button. So if you press the button, that is long press. So to prevent that, so here we return once equals to 0. When you while still pressed, then what will happen? Switch 1 is pressed, but once equals to 0. So the condition fails, no repeated action takes place. So when switch is released, again once equals to 0, system resets for the next press. So that is what this logic. So that is what this logic. When you release the switch once equals to 1 again, it resets. Okay, that is the code. Okay, let's run the code using MPLAB XIDE. So here we having two modes, right? Level and edge. It's opening. Please wait. At the same time, I am opening PICSimLab Simulator. Yeah, now, so I am not going to write the code again. So just here, open project. So here I am having project which is already done. So documents, embedded electronics, digital keypad. So under the source file we having .c files. Yeah, see here. So before that I will delete the other projects. loading. Yeah, so I'm not going to delete this, I'm just closing the project. Yeah, so here under the source file we having this one, right, digital keypad.c. Here you can see same thing I explained. So if mode equals to level detection, then it will return this. Else means edge detection. So here we having two. One is if condition. So when you press the switch, then what will happen? Once equals to 0, then return this. So else again it resets once equals to 1. And here you can see if key 1 is pressed, switch 1 is pressed, then RD0 is toggling, else RD1. So if you press the switch to RD1, similarly do the same. So here switch 3. So same thing you need to write for switch 4, switch 5, switch 6 also. Yeah, here you can see in the main.h LED is used for the port D, and yeah, so here LED 1 is used for not port D, so here RD 0, and LED array is port D, this one also. Similarly we need to write for the LED 2. So LED 2, LED 3 we need to write, similarly we need to write for the LED 2, LED 3. So here for LED 2 we need to write RB1. Okay, so now here you can see for LED to RD1. So here we written directly, right? So no need to write. Otherwise you need to write. And here you can see switch 1, switch 2, switch 3, 4, 5, 6, and this is for all released. And we need to write for the level detection. Yeah, that's all about the code. Save the code, then build. So why it's showing like this? So I'm just close the project and reopen. So okay, so here open project. Yeah, now this project is empty. You will need to add a file to the project before you can build it. This project is not empty. Okay, do one thing, just close the IDE, then again open it. Yeah, it's loading. So it takes some time. Yeah, now it's loading, right? So now here open project, then I'm selecting the board digital keypad. I'm selecting the previous one only. So gathering compiler symbols. So it's loading, little wait. So now before that, yeah, I hope you get this. So here this is the schematic diagram, okay. let's see in the source file. Yeah, so now it's proper. See, build is successful. So now open PICSimLab Simulator, then load hex. So here we need to select the digital keypad, and this one default production, this one. So now we need to, on the port D, we need to pull up this one, port D. So now when you press the RD0, LED should on, and here you can see D equals to read digital keypad of state. So what it will do, whether it will do level detection or edge detection. So obviously it will do the edge detection. So here we having parameter state. So if you have the parameter level, then it will detect the level detection. So now what we need to do, so go to the PICSimLab Simulator. So here press the switch RB0. Now keep press, long press. See here, no toggling, right? No toggling. So now what we need to do, again press the switch. It's off. Do the same thing for RB0, RB1, press, release the, so press the switch. Okay, see here, still it is on. Again you need to press, then it will off. This is what state change. So here LED is not toggling, it's toggling during the level detection. This is what state detection, state change detection. Okay, now go to the MPLAB XIDE. So here in the place of level we need to write, in the place of state we need to write level. Okay, save, then click build. Now go to the PICSimLab Simulator, then here reload last. So now here press the RB0, here you can see the toggling happens, right? Yeah, again do this. Yeah, here no toggling. Okay, let's check the code again. So yeah, here we need to add some delay, otherwise we are not able to see the toggling. So here also we need to add some delay. Okay, now go to the PICSimLab Simulator, again reload, then here you can see toggling. So that's all about the today's session. In the next session we are going to learning about SSDs, means 7 segment LEDs. That's all about the today's session. Thank you all.